Uh, yeah, these talks are being recorded because then we upload it to our Summer Institute in Computational Social Science seminar repository, which becomes accessible for everyone who's interested in these talks. Thank you, Erdem Hocam. This talk was particularly one of those talks that I've been, personally looking forward to because it is so interesting and it's such a huge project. So I'd like to introduce Erdem Hoca because that's the only bio that I have. I don't have the bios of other people in the group, so they can just introduce themselves. Erdem Yoruk is an associate professor in the Department of Sociology at Koç University and an associate member in the Department of Social Policy and Intervention at the University of Oxford. He is the principal investigator of the ERC-funded project Emerging Welfare, or the New Politics of Welfare Towards an Emerging Markets Welfare State Regime. He's also a member of the Young Academy of Europe and an associate editor of European Review. He holds a PhD from the Department of Sociology at Johns Hopkins University and a MA in Sociology and a Bachelor of Science in Electrical and Electronics Engineering from Boğaziçi University. His work focuses on social welfare and social policy, social movements, political sociology, and comparative and historical sociology. His work has been supported by the National Science Foundation, Ford Foundation, European Commission, Marie Curie Fellowship, European Research Council, European Commission, Twinning Action Grant, and the Science Academy of Turkey, BAGE. His articles have appeared in World Development, Governance, Politics and Society, New Left Review, Current Sociology, South Atlantic Quarterly, International Journal of Communication, Social Policy and Administration, Social Indicators Research, among others. His book, The Politics of the Welfare State in Turkey, is forthcoming from the University of Michigan Press. So we're really, really privileged to have Erdem Hoca and his research cohort presenting this very interesting, protest event detection and corpus work, which I think will be hugely important for a lot of people in our cluster. So they have been looking forward to this talk as well. So without further ado, Erdem Hocam, thank you so much for joining us. The floor is yours.
Oh, thank you very much, Akın Hocam and Emre, for inviting us. And I also would like to thank all of you for being here. And I would like to thank Hürriyetoğlu and Fırat Duruşan. So we, as the members of this emerging welfare team, have been working on this very challenging project for the last 4 years, 4.5 years. And we have been trying to use AI methods to extract protest information from online news sources in 3 different languages and in 6 different countries. And so we have been going through very challenging times, as I said, and so the grant duration is long enough to cover such fluctuations, but it seems that we are actually doing progress, and we are planning to release the first set of our data set next month. At the moment, we are working on to finalize the website and some more specifications. And let me share my screen. And before that, so I also would like to apologize for the delay. So I tested positive last Monday, and that's why we had to postpone this seminar. But I mean, I've been feeling very well. So last week it was a bit more uncertain. So it's good that here we are all together, and you're able to do this talk. Okay. So, as I said, so we are building an automated protest events data set. But why? I mean, what is the broader context in which we are doing this research? The emerging welfare, this ERC project aims at explaining welfare state development in a number of emerging market countries. And there is a welfare state boom expansion in these countries, especially on the basis of new income-based poverty alleviation programs. And we argue that this new development is not a result of economic, demographic, financial, in short, structural transformations, as is often argued in the literature. But we argue that we have to look at the contentious politics behind this huge welfare state expansion. And we have to look at how governments try to contain social movements, unruly populations, like armed conflict, with the use of social welfare provision. And in order to confirm such an hypothesis in a highly quantitative project, we needed to create our own data sets on both welfare and contentious politics. And we built the first data set, GLOW. I can write it down here for your reference. GLOW, QTR. So this is a large welfare state data set, and which acts somehow as our dependent variable in many of our analysis. And also we are building a GLOCON, the Global Contentious Politics data set. Let me share this website of this as well, although it is really not ready yet, but I will kindly ask you to come and revisit the website later in July. So you can have a sense of what the output looks like here. Therefore, so GLOCON is our main independent variable, and we are also using many kinds of administrative statistics, survey data, and we do analyze, qualitatively analyze parliamentary documents and government like the publications, documents, etc., in order to establish a robust causal argument between a causal relationship between contentious politics and welfare state outcomes. So, and the so the main question here is, what is the cause of this welfare state expansion in emerging markets, and does contentious politics play any role? And our main argument is that governments deliver these welfare programs or social assistance programs not when people become poor, but when the poor become radicalized. And we need to understand in quantitative terms how contentious these people are, and especially how contentious the poor people are. And we follow this larger definition of contentious politics as opposed to like social movements. Social movements are more structured, organized movements of the people. On the other hand, contentious politics is a larger umbrella term which includes any form of opposition against the governments or the power that be, and like that comes from the grassroots. And this includes street demonstrations, like labor actions, group clashes, like armed conflict, and like boycotts, occupations, like assassinations. And we have a really large, broad definition of contentious politics. And Fırat, as Fırat will tell you, so he has like worked excellently to draft and to create very detailed and intelligible annotation manuals, which is a key aspect of applying AI methods into social sciences. We have to make sure that our definition is clear and intelligible to everyone. So let me like give you an overview of this the protest event business, which traces back to 1950s or even 1930s. Social scientists like sociologists and political scientists relied most heavily on news archives in their efforts to create social movements data sets. And many people, including myself, worked to create such manual protest data sets. For my PhD dissertation, I created a protest data set for Turkey between 1970 to 2010s using Cumhuriyet newspaper, and I spent more than a year at Boğaziçi University library with this manual machine, microfilm machine. And it was terrible, and I promised myself that no one should ever again do this. And then it was 2013 and 14. I received a Marie Curie grant, and in this occasion, I came to learn that there are automated methods of doing this, and in this Marie Curie project, we somehow initiated this effort, and then with the ERC project, Dr. Ali Hürriyetoğlu and Fırat and other team members joined us, and we started to do something much more serious. And these manual methods, they are extremely so they are difficult. It takes time and money, and also it. I mean, once you finish your work, it is impossible to go back if you change your mind and your definitions but more importantly, news archives or newspapers have their own ideological and editorial biases. And these biases can only be minimized by including as many newspapers as possible, which is extremely difficult in manual coding. And therefore, all of these factors push the literature towards automated methods as much as possible. But the digital revolution and the rising computing powers, and so they created the supply condition, and an increasing number of automated protest event collection projects came into to the stage, and GDELT is the most famous one. So it's a huge project. They cover almost everything on Earth, but it is so it is a rule-based system. It has a really low precision and unknown recall. So I mean, transparency is perhaps the most important problem in this project. Again, ICEWS, so it is a fully automated but low recall project, and you are missing many of the events that are they're reported in the newspapers. And MMAD, again, another important project. They do a classification in an automated way, but they continue with manual coding. And as we will describe later on, I mean, even the automated projects and every single project in this industry uses like keyword filtering in determining which newspapers will be annotated to create the training data. And so we will talk about this, but we, as opposed to this keyword filtering, we adopt a random sampling methodology in order to attain like a cross context and cross language generalizability. And this is our objective. So we are trying to have a multi-country, multi-language system, and on the basis of language independent tools, so that we use different language sources. We do use our the English language annotations and Spanish annotations in order to predict events in Portuguese, for example. Therefore, so we see this project as an early attempt to have to create a real global multi-language protest event dataset that uses like local news sources. And I think, is this where I should stop? I think yes. I think Fırat will continue from here. But before I stop, I would like to emphasize one very critical thing. Our project, so it is a large team of people, and I believe that what we really accomplish is to create a real interdisciplinary research environment in which social scientists and computer scientists work together very closely. And I can say that computer scientists become social scientists to some extent, and we as social scientists are becoming like computational people over time. This is really important, and we built a new computational social science MA program at Koç University this year. So, by the way, the deadline is next week. So if you are interested, please check our website, and we look forward to your applications. And the objective is to create computational social scientists and to teach computational methods to social scientists. And this is really important, but even more important is to teach some social science to computer engineers. And we are really lucky to have Hürriyetoğlu. So he was he has a really good sense of social sciences, and he was trained as a computational linguist, and he understands social scientific concerns. And otherwise, I mean, most engineers, they just transfer whatever social and political biases and stratification mechanisms exist in society into automated systems. I mean, machines, the computers are poor people, so whatever you teach them, they learn and imitate it. But we know that society is really terrible in terms of race, gender, social class, sexuality, in every manner. And without considering this aspect, without considering such scientific and also ethical aspects, what you do is just to create an image of this terrible world in the eyes of in the world of computers. And yeah, this should be my last words, and I hope that more and more engineers should learn social science in the future in Turkey and beyond. Thank you very much.
I guess I take over from here. Can everybody hear me?
Yes.
Okay.
Yes.
Thank you. I'll start sharing my screen.
Maybe you can, Ali and Fırat, you can introduce yourselves briefly.
Yep. Picking up from the last point Erdem made, as much as there's a need of computer scientists to learn social sciences should also, in this day and age, learn a great deal of computer science in order to manage this line of research that is that benefits a lot from the interdisciplinary nature of the study. And I'm one of those social scientists who started dabbling in computer science. Not even that. I mean, like making elbow contact with computer science for the last 3 years, thanks to this project. My name is Fırat Duruşan. I'm a PhD candidate in the Department of Political Science and Public Administration in Ankara University. I have my bachelor's and master's degrees from Middle East Technical University. And as I said, I've been working in this project for the last 3 years. And my work in the project has concentrated on the creation of the gold standard, what we call the gold standard corpus, which comprises the training, test, and evaluation data that is used in training the natural language processing models. So I have worked with 2 teams of annotators, human annotators, and with them we coded quite a number of news articles, and to serve as the said training, test, and evaluation data. And in my presentation, I'll try to go into detail about how this gold standard corpus is prepared, why is it important, and certain challenges that are associated with the annotation process. So as Erdem said, the utilization of information technologies and information sciences, data sciences, shifted the character of protest data database building in social sciences quite a lot, in the sense that the ability to work with huge quantities of data, the ability to process huge amounts of data implied that previously unavailable amounts of data can be gathered and analyzed by social scientists, whereas in the old days, when, as Erdem said, this process was being done manually, it was quite labor-intensive and a long, drawn-out process. But the introduction of the automated methods brought with them their own set of challenges. And if you look at the literature on automated event data gathering, you see those challenges to be summarized in 2 main headings. The first issue can be labeled as validity. So the results of the event coding projects, the event data sets, to what extent do they reflect the real world in terms of events? So what is the level of correspondence between your protest data set, which is the product of your project, and the real world of events. Well, obviously, you can approximate to the real world events as much as your data source. So, so this shouldn't be understood as we're counting or collecting information about real world protest events. We're doing that, but since our medium is newspaper articles, we can only collect data about events that are reported in the news articles. So that's a caveat that should always be kept in mind. With newspaper data, even with textual data, even you have challenges that you must overcome in order to reflect what you have in the newspaper data source, in the textual source, accurately. So, some of the challenges that can be talked about under the heading of validity are event extraction challenges, corpus flows, and global the source variety problem. So to shortly touch on them, it's the event extraction problem refers to the difficulties of extracting relevant piece of information from the whole text. So it's not always easy to distinguish the valuable text, that the information that you're after, from the rest of the text. So, and this is arguably compounded by the fact that you will have in your database in the end a number of articles, a number of documents which will be talking about the same event. So a part of this issue involves whether you are able to count the events, take the events that are mentioned more than once in newspapers as separate events or as information about the same event. So that's an example of the issue with event extraction. So it's not only a document issue, it's also a cross-document issue. On the other hand, you have flaws in the corpus. Usually the what we call the gold standard corpus, or the training, test, and evaluation data collection techniques are usually opaque. Every project team has their own principles, and which are not usually documented well. And thus lacks transparency. And if you have flaws in your corpus design, your initial training, test, and evaluation corpus design, this will surely reflect on the data that you will collect in the end. And the third major flaw, the third major challenge is the sources, the selection of sources that you're going to work with. So the field is kind of dominated by the English language global sources. So sources like global news agencies like Associated Press, Reuters, and renowned internationally followed newspapers such as New York Times, Washington Post, and BBC Monitoring, etc. So to what extent do these reflect the occurrence of actual protest events, especially in emerging countries, countries that we focus on in our project? So that can be summarized as the issues of validity. And the other set of problems that are associated with automated methods can be labeled as reliability problems. So it's and this issue concerns concerns rather the scientific rigor of the data that you collect. So to what extent as a scientist can use that data reliably? And the problems the reliability problems become apparent when you compare different automated databases that aim to collect same or similar events from similar countries. And if you look at certain review articles, prominent review articles in the literature, you will see that more often than not, these databases will be in contradiction to each other. So the issue of determining which data set is more reliable vis-a-vis the others becomes a problem. This is compounded by the fact that the varieties that you're after, the phenomena that you're after, for instance, from our project, protest events, contentious politics events, they have their own variable nature. They will be experienced differently in different countries, different contexts, and even differently within the same countries across different time periods. And that variability will be compounded when you have different news sources with their own editorial standards or ideological positions, etc. So you need certain methods to make this variability more palatable, palpable for your project to work. So you need a certain level of simplification of the data, of this inherent variability, and which leads this necessity often, as Erdem said, leads researchers who work in these projects to use key terms to get a hold of the documents that they will use, and the key terms introduce inevitably a certain deal of bias into the mix. So and this will have implications, methodological implications all around. So also another issue would be in terms of the extent of the database, what countries or what context you use as your training data and training context, and what countries are you focusing on in terms of broadening when you're broadening your research. So if you train a model in a certain country and apply that same model in a different country, you will have losses in terms of reliability. So which will also make the comparative reliability difficult to assess. So in order to overcome all these problems, or rather a rubric that can address these issues in their entirety is the problem of generalizability. So we concentrated on generalizability from the outset as a principle that guide our overall methodology, so that the protest event ontology that we came up with and the automated tools that we develop in the end must be dynamic. They should be able to accommodate all the variability within our focus countries for the time being and in the future as well. So this was the main challenge that we aim to tackle. So in our project, the work package 2 is dedicated to the creation of this protest data set using natural language processing and machine learning tools. As a final product, we hope to achieve a fully automated tools that can create this protest database from online news sources from every focus country that we choose. So the online news sources, in the sense that they will be local sources, local to each country, so that we will hopefully circumvent the problem of source selection and the dominance of international news agencies in the field. So it will come up in other slides as well, so I'm skipping this part. Yeah, as I said, we tend to focus on the local news sources from emerging markets, our focus countries. Our focus countries are India, China, Turkey, and from Latin America, Argentina, and Brazil, and South Africa. So we work with local sources from each individual country, and we have, as Erdem also said, we have sources in 3 languages. The China, India, and South African news are collected in the English language, and Argentina news are collected in Spanish language, and the Brazilian news are in the Portuguese language. So it is Mexico and Colombia is also mentioned here. This is for future work. We're currently working with Argentina in terms of Spanish. So this data needs to be updated somewhat, but when we prepared this presentation initially, at that point of time, we had worked with over 10 million articles, processed over 10 million articles, downloaded from Chinese and Indian sources. And for the 2 countries combined, we have annotated, we have read 12,000 documents, which were annotated on the document level. That was labeled by our annotators to be relevant or not. And 1,000 of them were, 1,000 of these 12,000 documents were labeled on the level of each sentence that they contain, and 850 of those relevant documents that were labeled to be relevant, they were annotated on the token level, sub-sentence level, the details of which I will get into. So, yeah, as I said, there are 2 broad major steps in our work: is the corpus creation and the tool development. I touched upon these issues. So this is the pipeline that we divided our main task into. So you collect the news from online news sources. You download all the articles or the URLs, and in the initial task, the aim is to detect the relevant documents, those documents that contain protest events from all the other documents, all the other news articles that are related to other political news, economy news, paparazzi news, sports news, what have you. So it's important to emphasize here that we're not filtering in any case, in any step, the news with key terms or in any other news. So when our annotators read the documents, they read news reports of all sorts, and those contain that protest events are labeled as relevant, as protest documents. And in the following task, we work with only these documents, and we detect the event sentences within these documents. We added this task, the second event sentence task, later on in the process. We didn't start with, we used to start with the whole documents and move directly to token level, but we found that adding this extra step made things much easier for us to, in the subsequent tasks, the details of which Ali will go into after me. So in the third task, for each protest event, we aim to collect information about the participants of those events, the place of those events, event time, and what we call semantic categorization is what type of an event is that. So is it an industrial action event? Is it a labor dispute event? Is it a street demonstration? Is it a group clash, etc., etc.? So the fruits of that process, the database, looks, the final product looks something like this. So this is based on the Turkish data that was collected previous to our project. Actually, it was collected as part of Erdem's PhD dissertation project, and so this data that you see here, and you can review in this URL. It is open to access. The Turkish data showcases what the final product, the protest database, looks like. So for each locality that serves as a center of protest events over a given period of time, so this goes from 1970 to 2016, you have you see as a pie chart, and I think this pie chart is colored on the basis of the character of participants. So the blue stands for proletariat, the orange for students, etc., etc. So this is the final product that we aim to develop. This is this is a time series of the number of protest events that we calculated based on the Indian data. This is one of the preliminary results that we came up with. So we aim to see by virtue of this protest, among other things, the trends in the increase and decrease trends in protest action within a given country, and use that information, compare that information with the change in the welfare policies, as Erdem said, and make deductions on the basis of this causality or comparison. So if I can go a little bit into detail about the preparation of the gold standard data. As I said, we start with human annotation to create the training, test, and evaluation data for the development of automated natural language processing tools. So that is that's the key process, which serves which gives you, if you do this right, it helps you a lot in solving the problems of reliability and validity that I touched upon in the beginning. So the basic rule of annotation, whatever document, whatever database that you can come up with, whether it's fully automated or not, if it cannot be understood by humans, if it cannot be read by humans, it cannot be learned by the machine. So so the human annotation serves as the eyes of the automated tools, if you like. For this to work reasonably well, you have to define your tasks, your variables and rules clearly and understandably, so that the annotators will work with the utmost precision. You need to maintain consistency across all the temporal and spatial contexts that your focus countries present, and also you need to secure that consistency across languages and your source materials and news sources that you use. And you need to maintain that consistency over time. So what this all boils down to is the fact that you have to apply the same rules which are collected in our annotation manuals. You have to apply the same rules to each and every news document that you encounter. So as I said, we don't filter our sources in any manner whatsoever. So it's our sampling is completely random. In the literature, you will find the random sampling to be used as in a slightly different sense. So projects that use keyword filtering in gathering their initial raw data will also say that they collect that data randomly, which will mean that they don't pick from inside that data according to certain principles. So they randomize on the data that they gather by keyword searches. We don't do keyword searches, so we hold that our method is more random in terms of like the closest approximation to what you will get if you just randomly read every single news article that you can get hold of. Along with that, obviously, the annotators read every article, every single sentence, every single word, and decide according to what they read. So in order to secure annotation quality, we use double annotation. So every piece of annotation unit, be it the document, sentence, or the phrases, are the same document is read by at least 2 annotators. And this is the application of what is something that's called reasonable reader rule. So the reasonable reader rule indicates that you're after what any 2-person can understand from the news, from the text. So this is to minimize the role of personal interpretation or idiosyncrasy that people bring with their own personal backgrounds or interests into the mix. So that's why we use double annotation and adjudication and added to that. So double annotation means that annotators will agree on hopefully most of their labelings, and when they disagree, there will be a third eye, the eye of the adjudicator, who will spot these disagreements and resolve them. So in the end, you will have 3 eyes of the 3 human beings in every piece of textual data that you work with. And in our process, the annotators will give feedback into the annotation manual creation process, and this process, as it moves along, will be perfected. Small glitches will be dealt with, etc., etc. And also, in every step of the way, we take care to conduct random error checks. So whether these agreements were justified or they were like agreements on a wrong label. So our pipeline here serves as this the ground of this error check as well. So the relevant documents that are picked in the first task will be read on the sentence level, and if we can detect that a sentence was mislabeled in the previous step, the sentence annotation step will also indicate to you that it was an erroneous labeling. So this whole process is it's a virtual circle that in which every step feeds into all the other steps in terms of error checking as well. So we pick our annotators from graduate students in social sciences. So they have their own expertise in terms of understanding contentious politics events, and when it's necessary, the background information on the focus countries that we work with. So they go under a process of training in which they are trained in linguistic annotation, the basics of linguistic annotation, our event ontology, what we call contentious politics, etc., and some certain background information about the countries, about the focus countries. So the dynamics of contentious politics in India, China, South Africa, Brazil, and Argentina. How are they shaped? What are the most important social movements in each country? We give this training so that our annotators will have an easier time when they come across phenomena that are specific to those individual countries. So yeah, these are kind of repetitive. I'm skipping these. So if I go into a little bit of detail, in the document classification task, we apply a binary classification. So each document is either protest or no protest. So we have 2 labels. It's a relatively straightforward task. So we, as I said, we read every single report, and we don't pick, and we also label any kind of protest event that a news article contains. So the news article doesn't have to be an article that is specifically dealing with a protest event. So, for instance, you might have a news article about a football match in which you have a politically motivated fight between the spectators of each team, just off the top of my head. So that would also count as a protest event. And we are able to detect those articles because we don't pick relevant articles before labeling. So in the sentence classification, what we do on the document level on the sentences. It's again a binary classification, the protest, no protest classification. So this helps us in the we detect sentences that contain protest information, and the thing that we use, the anchor that we use in this is what we call event triggers. So event triggers are words like, it's either verbs or nouns that denote a protest event. So protest, demonstrate, strike, etc. All these are event triggers. So if a sentence contains this trigger, it is considered to be an event sentence. And from this step on, we only work with event sentences. We don't work with sentences that even if they have information about that said protest event, if it doesn't have this event trigger, event anchor, we disregard that sentence in further labeling. Further labeling is what we call the token level protest annotation, and so here we label the events and their arguments. Event arguments are time arguments, place arguments, as I said previously, and handling multi-event documents becomes one of the problems that we aim to solve on this level as well. So if a document contains more than one event, how to separate those documents, etc. So in practice, it looks something like this, what we do. So as an example, so this is from a document that is already this is from India, by the way. And it's from a document that is already labeled on the document level and decided that it contains a protest event. Each sentence is already labeled as a protest event or not. And in the final token level, Karnataka State Government Employees Association was the organizer of the event. Demonstrations was the trigger, the anchor of the event type, what we call event type. Across Karnataka is the event place. It is a state in India. Yesterday is the event time, urging the government not to go ahead with the new retirement scheme. So in this event, the demonstrators are targeting the government, so government acts as the target. So these examples showcase the main variables that we're after when we're working with protest documents. So we have two additional tasks in annotation. These are also done on document level. We also we label each document as to whether the events that they contain are violent events or not, and we want to classify the documents, the protest events, according to the demands that are enunciated by the participants. So we have non-economic, economic, and economic welfare demands. Those labels are put on the document level in this case. So this is obviously quite important in the context of our project. So this is the end of my part in terms of our project. So as you can see, we tailored this according to the needs of the Emerging Markets Welfare Project, and what is available in the natural language processing literature in terms of methods, techniques, and tools that are available that can be employed towards this task. So what I would like to emphasize, maybe as a final word, it is quite, this technique is quite, these techniques are quite handy in the sense that you can modify any piece of tool or method that you want to use according to your own specific scientific, in our case, social scientific needs. So if you're after the information of violent events or non-violent events, you can work on that too. And if you want to classify the demands, you can go for that too. So this methodology provides a huge opportunity in terms of to social scientists in terms of broadening their perspectives and increasing the rigor of their researches. So thank you so much for your time and for your patience. And I leave the floor to my colleague Ali to go into more detail about the more technical parts that I'm kind of ignorant about. Thank you.
Hi, hi everybody. I am Hürriyetoğlu. I am the computational part in this project with a lot of support from the social sciences. So it starts with social sciences and it ends with social sciences. And we are trying to find the balance between these two disciplines. I will just go into the presentation and let me know if there is anything I can be more explicit. The technology or computational techniques behind all this stuff. Do you see my slides, by the way? It should be technology behind it slide.
Yes, we do. Yep.
Perfect. So I will try to summarize these slides. So it has been already an hour and people may be a bit less attentive. When I started this project, I did a survey what people are doing and what techniques are there. It was 2017 and there wasn't much deep learning at that time. And there were a couple of, actually not couple of, many projects for collecting protest data. Even one was started 50 years ago by Philip Schroth. So I was learning and trying to find my way. We had to design a methodology that is that will not be restricted by keywords. So because it is an explorative study and we should find what is a contentious politics event in many contexts, in many languages. So therefore, we just collected a lot of data, whole archives of news articles. We got random samples and started to work with them. At that time, working with random samples was very expensive because you are annotating 100 instances to find 5 instances. So why we are annotating the remaining 95? It has the advantage to improve your annotation manual, not ignore minority cases, not just focusing on the popular cases or be affected by the media bias a bit less. You can't escape from it, but a bit less. And we were thinking we will need to go to more keyword-based afterwards or active learning. Actually, we applied the active learning. But then deep learning and BERT kind of technologies appeared and we checked. We were first adopters of this technology and the random samples were either equal or better performance, were yielding either equal or better performance. So the progress in state of the art helped us a lot. So we just remained in this methodology. The other side we kept, so when Erdem asks me, okay, what is the performance? I tell him it is 80 or 75, whatever. We had I wasn't confident in saying this and he wasn't sure how he should interpret this. So is this the one that is the best possible performance and would what this really mean in practice? So therefore to fill this gap in my own feelings as well, I found another project that was almost completing by Hans-Peter Kresi, POLCON. They work in same database. Actually, our annotation manual is a particular project, not because we were aware of them, and we compared their annotation manual after we had our own annotation manual. These people were kind enough to invite us to Italy. Me and Erdem went, and we talked to them. So what was the problem, what they achieved and not. And between 2013 and 2017, the methodology of machine learning wasn't enough for them to automate everything. So therefore, they did only the classifier, the first filterer, let's say, and then they did the rest manually. They still do it manually, and we need the manual stuff to validate our stuff at least. We are collaborating with them. So this was the first step. The second step, we went to a whole community in this line to organize shared tasks. So what would, we started in 2019, what would be the state of the art, output, the best output in a cross-context setting? So many people did their best to find the best possible numbers. So we established the state, we determined what would state of the art would do on these tasks. It is a set of tasks, document, sentence, token level classifications and extractions. And this brought two communities that have been working on these tasks for decades together. So socio-political scientists, more political scientists have been like trying to catch the automated approaches quite behind and to automate this task. But it wasn't that efficient. And the computational scientists have been like with a couple of benchmark data sets trying to beat each other by 0.1 better F1 points. So we played a critical role to bring them together, work together. We are organizing the 4th workshop this year. We invited like the most prominent people, starting with Philip Schroth. He has been working on this field from the very beginning. He established it. We invited Cleonat Raleigh. She is the director of ACLED. She was like, it was quite interesting. One was defending automated approaches. The other one was defending manual approaches by attacking the automated approaches. So we learned a lot from them. This year we have the keynotes from ICEWS, the other prominent database, and UCDP from Sweden, another one. Their director of these projects will be Tolkien. And many people who have been working in these projects or closely related topics are a workshop, let's say, and they're submitting papers and we are publishing proceedings. So this is a very hard task due to all issues mentioned by Erdem and Fırat, at least. And we are all just trying to shed light on different aspects of it. So therefore, we can't even say we are at the middle of the task, but at the beginning. Did I forget anything? Fırat summarized the keyword versus random sampling very well. One important thing in the generalization in automated approaches, especially machine learning. If I create a model, the best model today, with the data from today, it will not work equally good on data from previous 10 years or from data after 10 years or from data from another country. So we are keeping benchmarking state of the art in cross settings, cross context, same language. This year we started the cross-lingual and we were very happy with the results because it showed us the state of the art can be trained in any language in our setting, it was English, Spanish, and Portuguese, and predict data in Hindi. So if we want to understand what's happening in the Hindi language, so we want to go as local as possible, predict this information with 80% F1. 80% is quite good. So you are capturing most of the stuff without any data in Hindi language. So, this technology is just getting traction by big players in these days, although it has been around for 5 to 10 years. Now it is time for it. And we are the first to benchmark this stuff and having good numbers, I will show. So generalizability of the tools, the most critical thing. We have spent a lot of effort to be as consistent as possible to learn from the data, improve our annotation manual, or find a good balance between our abstractions. Fırat again did a great job there. And we keep monitoring the quality of the corpus. I will not, because Fırat mentioned a lot. The most challenging one is the token level. The agreements between annotators is a bit lower. Actually, anything below 0.66 Kirpandorf alpha is not considered as usable. So you should improve them as much as possible. Therefore, we are applying semi-automated error correction steps to improve these likely wrong stuff, or improve our annotation manuals and improve the data in the next steps. Otherwise, you can't learn anything from it, and you can't. And if you predict anything, you can't measure its quality. Fırat mentioned this, the sentence level annotation. This one is important, the event coreference. The main drawback of the available databases and limitation of the state-of-the-art computational tools is linking event records that are about the same information, the same event. So therefore, we are marking which sentences in a document are about the same event, and we take this into account both in modeling and prediction. And state-of-the-art has been working with sentence level data. So or you may miss more information, or you may have noise, because in average, each event is reported in 2 sentences. And this information wasn't known until we did it on a whole document, because till now, almost all projects are working only with leading sentences of the news articles, or first 100 words. I worked in 2010 in Europe Media Monitor, so I know these guys and we are collaborating a lot. And they think it is enough because they process 100,000 sources, and they believe if they can't capture a certain information in one source, they can capture it in another source. This is fine, but not everybody has the capacity to analyze 100,000 sources. This is argument used by ICEWS and GDELT as well. And we don't want to use this argument, because at the end you have the main patterns of the information, only well-written information, only popular information, only mainstream stuff comes. Although you have a very big database, you miss at least 20-25%. And in our recent paper, we checked the relevant literature from Strawn. I can find the detail if you are curious about. And anything minority or not mentioned in proper terms, let's say Western media, it will be lost. So from the very beginning, and thanks to the grant Erdem has acquired, and with the next one as well, we had the time and the capacity to go into all these details. This is what I summarized. You need to go over a sentence to get sufficient information about an event. So one sentence is not enough, or considering informed in a complete event record, this is not enough. So at the beginning, I said we were spending a lot of time and effort to identify these positive cases, positive text. But when we use a recall biased classifier, sometimes an ensemble one, we could get like almost 20 times decrease in the time or money we spent. But we lose 3% recall. So this 3% recall, until we measured it, there wasn't any sense of recall in anywhere. By the way, we have the assumption that random samples from the whole archive represent the universe of these events. So we did this one like a brave team of researchers, spending a lot of money on it. Just now, this year, I have seen two important papers published in important places, and these people, we have contact with them. We invited them to a workshop, to Zurich, whatever. The new effort is toward measuring the recall. ICEWS project has tried this with a bit less reliability, let's say, to measure the recall. So measuring the recall is one of the very important parts of this work. But still, although we know this active learning stuff, we keep measuring or evaluating our systems on complete random samples. So the first step of our systems, because we were inherently multi-country, multilingual project. So how would my system, a state-of-art text processing system, would perform in another country with the same language? So the drop of the performance is 10%, at least 10 points of F1. This is a significant one. So if I train the system or optimize the system for data from India, and I just took it without any change to process data from China or UK or US, whatever, I lose 10% or 10 points of F1. This is significant. This is important. So, and it wasn't measured before. In some projects, you may say, okay, fine, 70 is fine. I will measure a lot of sources, data from a lot of sources, and it will be fine for me. But now you can say, okay, this is fine for me, and I know what I am missing, and I make this decision consciously. And we are proving again the same thing in the generalizability problem that is known in machine learning and computational linguistics for this domain. We had the 3 tasks. Test 1 is about document classification. Test 2 is about sentence classification. And then we have the token level event extraction as the 3rd task. The performance is a bit lower there, but still those in 2019 were the best systems. And now I could tell Erdem we were close to these numbers because we were using BERT starting in 2018, March. And this task was in 2019, and none of the systems were using BERT. So therefore, thanks to the advancement of the state of the art and some capable colleagues, we were already getting numbers like this. Another thing, we used the random sampling. We get a lot of data, but we were not really sure whether we are doing the right thing. Although you do the wrong thing or spend much more money than usual, we were still curious about it. So with the hope, wishful thinking of maybe we did quite good job. Again, state of the art helped us a lot. We got a couple of keyword sets that have been used in these studies: Wang-et-al, POLDAM, MMAD, and event status. And we tested them on our random sample. We tested deep learning models that are trained with these restricted data sets and non-restricted data sets. Thanks to the deep learning era and advancements, random samples did either comparable or better performance, they yield. And in one context, in the cross-context setting, the random sample did much better. So, and we were quite happy about it. It was a risky statement, and I tell some times to my colleagues, like, I didn't know any better methodology, and we had to start from somewhere, and it turned out to be a good timing, let's say. It came with a lot of advantages. This is the best keyword data set, like sometimes it drops a lot, like here 66, 56 when you train on India and test on China. But here the numbers do not drop that much. Here you have 88, it is 86. For China, if you get data from China plus South Africa and you predict India, you have these numbers. But with a random sample, you have these numbers. So there's a clear improvement. And without, in a paper writing scenario or any peer review, we would object each other, like, why you are using these keywords and not another set of keywords? How can you prove this is not an arbitrary choice of keywords? So these are quite critical and affect validity and reliability of your study. Therefore, this random sampling have been doesn't have these problems. So another thing, just because we have the setting, we tested what would happen with, there are new class of deep learning models. They are multilingual. We call them like MBERT, not BERT, but MBERT. There's XLM, Roberta. And we thought, so we have data in English, Spanish, Portuguese. What happens if we merge all this data as training data? So it is better than the monolingual models at the end. If you don't have, if your setting is monolingual one, use the monolingual model. It performs better. But if you are in a multilingual setting like ours, just merge all of your data. This was our test last year. But again, we had to check with the world how people are doing. We organized the shared task and we got similar and even better results. There was a team from IBM who did really amazing. So this is the task from shared task from this year. We will be at ACL. It is the highest level conference, top level conference of computational linguistics. And we introduced this task to these guys, and we know them even better. So we have worked together to generate this stuff. We have 4 tasks. One is document classification. This you see the results of the document classification. The subscripts are ranks. So here you have like 84 and half, and this is 8. The second one is this. And we had the training data from English, Portuguese, and Spanish, and test data in English, Hindi, Portuguese, and Spanish. So participants combined the data or translated the data in many scenarios. Most of the time, the multilingual models did the best. We didn't have much training data for Portuguese and Spanish. We call it fifth shot learning. And for Hindi, we didn't have any training data, and it is zero-shot learning. Look to the 78. So first numbers were like 54, 59. We thought it will not work. But then we got quite good submissions. And participants doesn't see the test data. There isn't any possibility for them to hack it or find anything. So therefore, we were quite happy about it. And tell people, actually, any researcher from any country just prepared, let's say, 300 documents as evaluation data, and we can tell them how is the state of art is doing for them. And this data set was added by a team in India. This is task 2, sentence classification. Here we see quite a difference between the submissions. So this is the team from IBM had a lot of compute power, and they really took the limits of the task. So because they're using multilingual models, they were not the best here. A monolingual model did better than them. But in other, like few-shot scenario, they are quite better than the other teams. And again, there is a continuum after them. This is the, let's see, this is, I was planning this one to be the, anyway, we are trying to find the relation between sentences, how likely it to be optimized, or what will be the performance. We have similar numbers, similar differences, and this one, the token. Which one is this? No, I don't have them. Actually, I can show them to you from my folder, just to show you the difference. Like without knowing or organizing this, we would think, okay, the best you can achieve is 70 or 60. But when you work with all these people, they really show you what is the best possible outcome you should expect. Let me find you this one. Yeah, this is it. This is 5. I show it to you. This is 6. This is 7. Yeah, let me show you. This is the, do you see the table, or should I maybe better open it? This is the sentence co-reference. So how likely you can identify whether two sentences are talking about the same event. We have quite good scores, so you miss information. So you see errors that you would say fine if the machine can't capture this, and easy cases, normal in terms of hardship cases are captured. This is for sentence co-reference. The best numbers and second numbers are, you see the difference, like IBM did 3 points above. And actually, these 3 points are quite significant, because in coming years, we will see like some people will come, will do 85, and they will be very proud of themselves. Just because it will get just harder, and it is hard to obtain such differences when you compete in the same state of the art setting. So this is 1, this is the second, not much difference, and this is 84, and this is 83, not much difference. The actual difference, the striking difference for us was this one. This is like IBM did 4 or 5 points better than all others. Like, look, from 88 to sorry, 78 to 73, from 73 to 68, and from 66 to 62. So without this team, you will think, okay, the best possible thing could be around these numbers, and you should accept it as the truth. But like, luckily, these guys came and showed us like, okay, guys, don't stop. And those are core computational linguists and machine learning experts. So therefore, we benefit depending type of the tasks and languages. We have good community around it. This is from last year, if I remember. No, this is our own data with much more data. We will update them in the multilingual setting. I will provide a reference that you can go and see all these details. We have semantic event categories. If you want to understand whether it's a group clash, industrial action, demonstration, or armed militancy. We have semantic types for organizers and participants. Again here. Yeah, and we just working on more detailed scenarios, trying to understand quality of the whole database, like are we able to capture caste movements? Are we able to capture ideology related movements or woman related events? And just soon we have prepared its base. We will be creating a global database of protest events from international sources and local sources in all languages, because these multilingual models work in 104 languages, and maybe now it's for more. And even these models work in for some languages better, and for some languages not that good. When you merge all the data and push the all technology with these helpful guys, you reach quite surprising good results. That is it. We have actually whatever we have talked are in these publications from this year. If you want to go to the annotation manual is summarized here, but you can go directly to it. 60 pages of content, quite good one. This is the demo. Erdem has shared it in the chat. And if you have time and want to know how is the community is doing, we will be August 5, 6 online at ACL. Please register or let us know how we can share with you more. And the proceedings from previous years are available as well. Just either look at our EMW webpage or let us know. So we are setting and leading what's going on in this line. So thank you very much. This is from Erdem, and you can find our email addresses very easily from anywhere. We have a community, not very active in times of other, in general times, but this is an email list. We are gathering interest and discuss before proposing a project or a workshop. Thank you very much for your time. This is it.
All right, thank you so much. This was incredibly exciting, and it's really like path breaking in a lot of ways. So thank you so much. So I think Venya is raising his hand, but before that, I think Oğuzhan İzmir asked a question.